Today we're going to be looking at patterns and functions. So a function is a relationship that assigns exactly one output. So a relationship that assigns exactly one output which is the value of y for each input value, which is x. So the function rule, that is just an equation that describes a functional relationship. So if something says, what is the rule? It's meaning, what is that equation to describe it? So taking a look at example 1, we're going to use this fact to fill in the table. So this is our rule, our equation, and we're going to use that to fill in our table. So the principal invested, that is our independent, that's our input, which is our x's. The C, which is our value of our account, that is our output, which is our y. So when I'm trying to find my C, my y, my P, which is my principal invested, would change to 100. So then plus 0.06 times by 100. So when I plug that in, we end up with $106 in our account. So let's see what happens when we have 200. So I'm going to do 200 because it's my principal plus 0.06 times by my principal, which is 200. Then I would have $212 in my account. If I had 300 for my principal, 300 plus 0.06 times by 300. So that would mean I had $318 in my account. So then the last one, if I did 400 for my principal plus 0.06 times by my 400, I would have $424 in my account. So for example 2, the relationship in the table below are shown. We need to write a function rule. So we are trying to find the equation. So in order to do this, I'm dealing with pounds of candy and total cost. So this is my input, this is my output. So my x and y. So I know since my total cost is my output, I'm going to end up with C equals something, because that's my cost, equals. So in order to identify this, we first need to find a pattern. So that's our step 1. So in this case, our pattern, if I'm starting at $3.50 and I'm going to 7, I'm adding $3.50. If I add $3.50 to $7, I get $10.50. If I add $3.50 again, I end up with $4. So my pattern is $3.50. What we are trying to identify here then for the second part is what would happen if our input is 0, meaning these values here is 0. So if I go backwards, because 1 after 1 is 0, what would that value be? Well, if I'm adding $3.50 each time, that means if I'm working backwards, I'd be subtracting. So if I'm at $3.50 and I subtract $3.50, I'm going to actually end up at $0. So if I do work my way down, 0 plus $3.50 is $3.50, and then it keeps going. So when my input is 0, my output is also 0. So when I write my function rule, my pattern is always multiplied by my input, which is going to be stand for P for pounds of candy. And I'm going to be adding 0, because that's what my x value is at, 0. And so my rule is C equals $3.50 times by P. So So now let's take a look at the next problem. So again, let's start by identifying our pattern. So step 1, what's our pattern? I'm at 12, and to get to 21, I'm adding 9. 21 plus 9 gets me 30, and 30 plus 9 gets me 39. So my pattern is a 9. So then I want to look at my input is 0. What's my output? So if I'm at 1, and I go backwards 1, I'm now at 0. So if I work myself backwards, if I'm at 12 and I'm working backwards, I'm not going to add 9, I'm going to subtract. 12 minus 9 actually gets me to 3. So now if I work the other way, 3 plus 9 gets me 12. So when I'm at 0 for my input, my output is 3. So to write this rule, I'm going to use W for my wages earned is going to equal, I'm going to use T for time. So 9, actually no, let's not use T, let's use the H for hours. So my pattern is 9, so I'm going to multiply that by my hours, plus I started at 3 when it was at 0. So there's my function rule, 9 times H plus 3. Let's look at the back side. When we're dealing with domain, domain is our input values, and our input values are our x's. The domain works with independent variables. They are one and the same, so independent variables provide input. So what you're going to put into the equation, an example could be our hours worked. So you're inputting how many hours you worked. Hours worked. The range is our output values, which are our y's. So that makes them dependent variables because they depend on the independent. So what you choose to use for your independent will affect the dependent. So example would be your independent was the hours that you worked. So how much you get paid, so your total money earned would be your independent because it depends on how many hours you worked. So let's look at example 3. Mary earns $7 per hour for babysitting after school on Saturday. She works no more than 16 hours a week. So the independent variable, there's two different things going on. She's working some hours and she's making some money. So her independent variable is how many hours she worked. And my dependent is how much money she makes. How much she earns will depend on how many hours she works. So her domain, since it's the hours she works, it states that she works no more than 16 hours. So she could work 0 hours for a week, decide not to go, she didn't have time, but she can't work any more than 16 hours a week. So that's her range. So she can work 0 hours, she can work up to 16, but no more. Her range deals with her dependent, so how much she earns. So if she works 0 hours, that means she's making $0. If she works 16 hours, she's making $7 an hour. So 16 times 7 would be 112. So her range would be she could make anywhere from $0 to $112 in 1 week. We need to complete the table and write a function rule. So if I'm taking a look here, I'm going from $10 to 24, so I'm adding 14. 24 to 38, I'm adding another 14. So if I keep this pattern going, the number of hours of piano lessons, if I did 4 hours of piano lessons, it's going to cost me $52. If I add another 14, if I work for 5 hours of piano lessons, it's going to cost me $66. So I found that the pattern is $14. Remember, step 2 is you have to look at your input when it's at 0. So if I'm at 1 here, if I just go one more up, I'm now at 0. So remember, if you work yourself backwards, so if I was adding 14 and I'm going backwards, I'm going to subtract 14. 10 minus 14 is actually negative 4. So if I did negative 4 plus 14, I would work myself and get myself back to $10. So when my input is at 0, my output is a negative 4. So when I go to write this equation out, my total cost will be my pattern, which is 14, times by the number of hours that I did my piano lessons for. But I'm going to subtract 4 hours from that because that was my 0 input value. So for number 5, the graph models the relationship between the cost and the storage capacity of memory sticks. So the things you stick into your computer so that you can save files. What is the independent value? Well, remember, our independent value provides the input. It's our x values. So if I'm looking at this graph, my x values are down here. This is my x-axis. So my independent value variable is my memory, which is done in gigabytes. The dependent value depends on the independent, which is my y values. So I'm looking here. This is my y-axis. So it's going to be the cost. How much it would cost me to buy that memory stick that has however many gigabytes. Is the relationship a function? Yes, this is a function. We stated before that a function is the relationship that assigns exactly one output value for each input. So when I had an input of 1, I only have one output value. When I have this one, I only have one output. One input, one output, one input. So you're looking to see here, there's only one dot on each of those, so this is a function.